Both of them are functions, so we can sketch it. Y equals square root of x is going to go that way. Yes? And y equals square root of 1 minus x. It's just a shifted version. Agreed? So instead of starting at 0, it is going to start at 1 and go that way. Yes? Probably that. Good approximate picture. Now, if you do the reflection, you've got one side here, another side over there. Yes?
No.
Wait,
Yeah.
why not?
It doesn't look like that.
You grab 1 minus x, 1 minus x.
Your purple one is
Is that even?
Wait, why is my purple one incorrect?
just because it's a negative.
It goes, how does that even work?
Negative.
Thanks. That one. Went the wrong direction. 0. Now you've got two choices. Which one should we pick? Well, some of you initially picked this part because, sure, it is an enclosed area, but is it really enclosed though? It is not. Why? This part right here is enclosed, but did I say that it is bounded by x equals 0? Did I say that the curve stops? I didn't. So this keeps on going. If this keeps on going, do we have a finite area? No. If we don't have a finite area, are we going to have a finite volume? No. So can't be that. Unless you want to get the problem wrong, it can't be that. So it has to be that part. So that is our region. Good. Now, I don't want to. Well, I guess I could draw it. I will try. I'm no artist, but I'm going to try. That is x is equal to 4. Good. We'll set up or start with the integral. This way, we can figure out is it going to be y, x, bounds for y, bounds for x, one at a time. So, integral pi outer radius squared minus pi inner radius squared. Agreed. What are we integrating with respect to? Spinning it about the line x is equal to 4, which would simply mean this is parallel to that. Agreed? That is the y-axis. So it has to be dy. Okay? If this is dy, the bounds, they have to be 4dy. Or simply put, y. Agreed? Okay. Where does y start?
0.
0. Okay. Where does it end? So it starts here. Tell me when.
What's up?
Right there. Good. And what is that value? That value is the point of intersection. If you put it in the calculator, it's 1/2 comma 1 over square root of 2. 1 over square root of 2 is nothing but 0.70%. Approximate. With me so far. Now, what are we supposed to do at this step? Now that we've written everything, draw the strip, learning finally. So, outer it's the length here one. The other one is this. The shorter one, good. Good. I want to find that radius and that radius. If I find those two, I'll be done. That radius is not a fixed value. Do we agree? This is going to change if I move that up and down. Agreed? And the only way for us to connect the radius to this region is using those curves. So somehow we've got to relate the radius to the curve. Well, arbitrary x. Let's say, to avoid confusion, arbitrary x out. Some x value that would correspond to the outer curve. Arbitrary x value right here, which would correspond to the inner curve. Good. Okay. This is what I have from that picture. I have 0 to xl. Good. And then I have the outer radius. I put them together, I get the total length from 0 all the way up to 4. Do you agree? Good. If you can't visualize it, basic algebra, x plus r out equals what now? 4. Is it possible to solve for the outer radius? Alison? Yes, so what is it? 4 minus x out or x out? Right. Same logic. As you move this red strip up and down, it is going to vary with respect to the purple curve. You have 0 to x in and x in to 4. So this length is x in, that length is r in, this plus that equals to a total length of 4. I want to solve for the inner radius. Good. With me so far. Next step, let's write the upper limit, 1 over square root of 2. 0. Pi is common to both terms. 4 minus x out, entire thing squared, minus 4 minus x in squared. Good. Integrating it with respect to y. Here is another tip. If this is going to shift by 4, that has to shift by 4. If you see a 4 here, there has to be a 4 there. It's a given. Easier way to remember. Okay, I've got the bounds for y because it's moving up and down. It is dy because it's moving up and down. But whatever I wrote here are in terms of x. Somehow I want to convert them to y. How would I do that? Hannah, right now. Hannah? What's your name?
Me? Oh, Megan.
Okay, good. Do you know the answer? Go ahead.
Wait,
Yeah.
what was the question?
How do we rewrite it in terms of y?
Oh, well, the y equals square root x would be x equals y squared, and then that one would be 1 minus y squared.
Do we follow that? Caleb, what was your answer?
What's one of those?
The same thing? Okay. Let's erase this. Okay. Since you have R out and R in, and both of them are going to vary with respect to the curves that you have, R out is going to move back and forth along the green curve. Do you agree? When you sketched it in your calculator, Desmos, whatever, that green curve corresponds to which one here?
Square root x.
Square root of x. So, y out or r out relates to x out. I just want to solve for x out. How do we solve for x out? Sorry.
You wanna square it?
Square on both sides. Y squared equals x out. Back over here. Pi integral 0 to 1 over square root of 2. 4 minus y squared squared. Good. I'm just plugging in y squared for x out. Likewise, as I move this red strip up and down, up to the point of intersection, it is tracing out a curve that I messed up when I first drew. So which curve? The red strip. It's moving along which one, Alex?
The y equals, or x equals negative y squared minus one
Okay,
plus one.
plus 1. Okay, so over here. So this curve. So y would equal the square root of 1 minus x in. How do we solve square on both sides? Y squared would equal to 1 minus x in. We want to solve for x in. X in is simply 1 minus y squared. 4. As I went around, people didn't listen to me as always. Didn't put parentheses. Minus 1 minus y squared. Don't put that parentheses, you are going to make a mistake. Good. Okay. I will rewrite that integral over here. Pi 0 to 1 over square root of 2. 4 minus y squared squared minus 4 minus 1 minus y squared squared dy. Do I have the entire integral written in terms of y? Yes or no? Yes. So everything is in place. All we have to do is integrate it. So great. Before we do that though, distribute, simplify. That one. And 4 -1 minus times minus plus. So plus y squared and 4 minus 1 is 3. So 3 plus y squared squared. Good so far? Yes. Okay, what did we do at this step? I'll go back up here. I'm still waiting. Foil, okay. So pi simplify it before you start integrating. That's the best way to do it. So if you FOIL the first expression, you have 4 minus 8y squared plus y raised 4. The second expression minus parentheses 9 plus 6y squared plus y raised 4 dy.
I think
Yes.
that 4 is supposed to be 16. Because if you did 4 times 4.
But not. Friday. Okay. Getting way too excited. Thank you. 16 minus 9 is 7. Negative 8 squared minus 6y squared. I meant to say negative 8y squared minus 6y squared. Negative 14y squared. Y raised 4 minus y raised 4. This is 0. Good. What is the integral of 7? 7x. Integrating with respect to y. 7y. What is the integral of 14y squared?
Negative 14 y cubed.
Negative 14y cubed divided by 3. 0 to 1 over square root of 2. I don't have to worry about the denominator, sorry, the lower bound, because y is 0 would mean both of them go away. So pi times 7 over square root of 2. 7 over 3 square root of 2. Pi times 14 over square root of 2. Yes? You can put it in decimals. So 14 pi over square root of 2 is what my mental math is telling me. But
Oh, okay.
so when I simplify last problem, I wrote, 7/square root of 2 minus 14/3 rooted. I simplified those two, and then I did the common denominator. I forgot that 3. It is 14 pi/3 root 2. So I forgot that 3. So naturally, you would have tried to sketch this using a calculator. Did we make that change in the previous problem? 14/3 root 2. 14 pi/3 root 2, yes? I don't want you to get confused later. Naturally, your mind would say, oh, I'll go ahead and graph this. Did we graph it? Okay. Cube, it probably goes something like that. Press around that, it should go like that. Agreed. The fourth power, probably going to go like that. Yes, approximately, as I went around.
Supposed to be getting that.
What?
No, probably supposed to be like inward compared to the other one.
It's moved a bit. Is that what you're
Not
saying?
moved, but like.
The parabola
it's too
grows
far
Oh,
out.
it's too far up. Okay, my bad. It should go this way.
Yeah.
Is that what you're trying to say? Okay. This way.
Yep. perfect.
Okay, fine. As I went around, the number of you take that region and tried to spin it around. There is a huge problem with that. What is the issue?
It's infinite.
Unenclosed.
Infinite area. It is not enclosed. If you have an infinite area, are you going to get a finite volume? No. So, problem. What are you going to do? Abort mission? Yes. You are not able to see it in your calculator because the value where it intersects is extremely small. The only way you would be able to see it clearly if you zoom in a really granular manner. Perhaps I will show you next time to be continued. But in a problem like this, where do you get the insight from? I am looking for a point of intersection to get an enclosed area. Do you agree?
Yes.
Okay. It cannot be over here. Do you agree? It cannot be over there. Do you agree? So none of that, none of that. We have already established it can't be this. Correct? No. It has to be there. Because I think they're going to intersect. What is the easiest way, if possible, algebraically, to find the point of intersection? Set them equal to each other. X raised 4 equals x cubed over 3. Yes? They will get cancelled. X equals 1 over 3. So the point of intersection
How do they cancel?
how do they cancel? Algebra. Come on, Caleb. X cubed over 3, yes?
Oh.
Divide by x cubed on both sides. X raised 4 over x cubed equals 1 over 3. Move it up. You don't believe?
I believe that. Let's go. I get it.
X raised 4 minus 3, 1. If you don't believe me, plug in 1 over 3 here, 1 over 3 there, and tell me what you get. You will get 1 over 81. And 1 over 81 is a pretty small number. It's probably 0.013 something. 0.125. Huh?
0.123456.
0.1. It's not 0.1.
No.
1 over 8.
0.01.
Okay, 0.012 something, right? It's a very tiny number. So you've got to zoom in really to get to that point. Well, do you really want to do it using a calculator? Well, you can't. I'll show you how to do it next time. But I wouldn't rely on a calculator, you'd be wasting time. I want you to set this up, do just the setup. Find the volume if you can. I'm going to finish this problem and I'll start method of cylindrical shells.